Hello and welcome to the Fundamental Counting Principle, Part 1. Okay, to show you what the Fundamental Counting Principle is, I'm going to set up the following situation. Suppose you had 3 cards, and on the first card you had the letter A. On the second card you had the letter B, and on the third card you had the letter C. Now my question is, how many different ways can I arrange these 3 cards? So we're asking ourselves how many different arrangements. Okay. All right, so that's the question. And luckily, with only 3 of these cards, it's not too bad to figure out, even with something like a tree diagram. So that's what I'm going to use. I'm going to use a tree diagram to illustrate how we get the answer, and then we're going to expand upon that method, which is the fundamental counting principle. Okay, so let's see. If we picked our first card, we could pick an A, or we could pick a B, or we could pick a C. So there are, in fact, kind of 3 choices here. So here's my 3 branches for the first card. So here's card number 1, or the first card that I lay down. I have 3 choices there. Then we go to the second card. Well, if I've laid down the A, then for the second card, I have a choice of either B or C, right? B or C. So this is for the second card. And same thing here. If I put down the B, then I would have a choice between A or C as the second card. And if I put down the C, I have a choice between A or B. Okay, now that's the first 2 cards put down. Now if we go to the third card, I don't really have much choice. If I use the A and I use the B, then I guess the third one is C. If I used A and then C, then the third one is B. If I put down a B and then an A, then I guess I've just got the C left. B followed by C leaves me with the A card. And finally down here I got C, A, and then this would be the B card. C, B, and finally A. Okay, now if you look at these branches, these are all of the possible arrangements or different orders that we have for the A, B, and C cards. So there are, in fact, 6 arrangements. So the tree diagram worked quite well. There's just one little problem. What if somebody comes along and says, there's more than 3 cards? Maybe there's 12 cards. That's too much to draw on a tree diagram. So the tree diagram method doesn't work well if the amount of objects gets too big. So we got to figure out another way to look at this, and that is going to be the fundamental counting principle. And it works like this. It's kind of like the tree diagram without drawing the tree. If we go to the first card, how many choices did we have? Well, we had 3 choices for that first card. Okay, so we go, yeah, 3 choices. Then if we look at the second card, well, depending whichever card you laid down as the first one, there was only 2 cards left to choose from. So there are 2 cards remaining to choose from. Followed by, once you've laid down the first and the second card, there's only 1 card left. Now look what happens if I multiply all this together. It's kind of like multiplying and counting your branches here, isn't it? I mean, you're getting the right answer. So really, it's kind of like saying, I got 3 branches, and for each one of these 3 branches, there are now 2 branches, and then for each one of these second branches, there's only 1 branch left. So that's kind of what we're doing here. It's kind of like counting up the branches. Anyway, this is the fundamental counting principle. So you just think of it this way. For your first spot, you have number of choices. Okay? It'd be no different than figuring out how many different branches you would draw. And then the same thing for you go to the second branch and you say, well, how many choices do I have now? In other words, how many branches would I draw? And so on, all right? Same thing over here, number, and so on. Okay, so let's go now, clear the screen, and do an example. And this is the very popular license plate example. Okay, so license plate example. Now, what we're going to try and do is figure out how many different license plates are possible. And the license plates we're looking at have 3 letters, followed by 4 digits. Okay? Now the letters include any of the letters of the alphabet, and the digits include any digits from 0 through 9. So here's how I usually set it up. I start off with how many choices do we have for that very first letter? Well, there's 26 letters in the alphabet, so we have 26 choices, followed by 26 more choices, because there's 26 letters in the alphabet, followed by 26 more choices. Okay, there's the letters. Now we're into the digits. Now, if you count digits from 0 to 9, there are 10 digits. And, of course, there are 10 more for the second number, 10 more digits for the third, and 10 digits at the end. Well, this turns out to be a huge number. It turns out to be 175,760,000. That's a lot of different license plates. One thing to keep note of here is that this allowed repetition of letters and digits, so it allows repeats. And also, very important is order mattered. You know, we might be using the same letters and the same digits, but we've changed the order on it, and that counts as a different license plate. Now, what would we do if we had the same situation here about license plates, but we said no repetition? Repetition. Allowed. Okay? Then you'd still start off and say, yeah, there's 26 letters to choose from. But now when I go to my next letter, I only have 25 to choose from. And the reason is I can't let it be the same as the first letter was. And let's say we picked a B, then I can't use B again because it says no repetition. So there's only 25 to choose from. Similarly, there's only 24 to choose from for the third letter. Now when I get to the digits, I got 10 to choose from, and then 9, then 8, and then 7. So now I've got all of my license plates thinking done. How many is that? 78,624,000. All right, and these have no repetition in them. And that's where I'm going to stop for now with regards to the fundamental counting principle. Catch you later.